So on the front of these notes, we talked about our math keys, which are basically just the keywords we're looking for each operation. Now we're going to be converting those verbal expressions, the entire sentences, into an algebraic expression. So we're still going to be looking for those keywords, but there's also really special words and phrases and punctuation that we need to be aware of when we're converting the whole sentence into algebra. Okay, so we're just going to go through a handful of those, and then we're just going to do some examples together. The first one says 6 less than a number. We know from the front that less than is telling us that we're using subtraction, but there's something that happens that's really special about the phrase less than. If you see subtracted from or added to, all three of those, actually from, then, and to, those three words are telling us to switch the two terms around. And when I say the two terms, I'm really talking about the two terms on either side of that phrase. So we have 6 less than a number. Those are the two terms. A number can be represented by any variable. I'm going to choose x every time, but we're talking about 6 subtracted from, taken away from a number. So we have that number, we don't know what it is, but there's some number here, and it's 6 less than that. We need to write it in that order. If we don't, it means something completely different. 6 minus something is different from that something minus 6. So anytime you see the phrase less than, more than, added to, subtracted from, those all tell us to switch the two terms around, and it's the two things on either side of that phrase. The second one is a perfect contrast to that, the difference of twice a number and 3. Actually, I'm going to flip that around. I'm going to change those to blue. That's what I did the first time. Yeah, let's flip that. I'll change this to yellow. Alright, so the difference of, that's telling us also subtraction, but it's actually saying just do it in that order. Twice a number, which is 2 times a number, and 3. The difference between these two things, the subtraction problem between twice a number and 3. The next one's kind of similar, talking about the quotient of, that's telling us do it in this order, the quotient of these two things, 4 and a number squared. So you can see that word and kind of separates the terms. The quotient between these two things, 4 and some number squared, the division problem between 4 and a number squared. You could also see that as a fraction. If I can get rid of that thing, that's not what I wanted to do. So you can also see that as a fraction, 4 divided by some number squared. Alright, the next one is saying the product of 7 and a number, comma, cubed. That comma is extremely important. That comma is saying we're separating whatever this stuff is, all of this stuff, all of that, and whatever this operation is. So we're talking about the product, the multiplication problem between 7 and a number, and then we have that separated from this cube part. We're going to put that entire quantity in parentheses, 7 and a number being multiplied, because that's what product means, and that whole thing in parentheses cubed. That's very different from just saying 7 and x cubed without the parentheses. That's just cubing the x, whereas this sentence is telling us to cube the entire thing. The whole product is being cubed. And I have a really good example of why that's important. Alright, so this is why we really need to be careful with our commas. A comma tells us that this first phrase is separated from the second phrase. So in English, if we read this, let's cook, comma, mommy, that's saying a child is telling their mom that they want to cook. Versus let's cook mommy, that's saying they want to cook their mother. Those are very different things. It's the exact same thing in algebra. If we're saying the product of 7 and a number cubed, where this is separated by a comma, it's the entire thing cubed. Whereas if we didn't have that comma, it would just be the number cubed. Alright, the fifth one's saying square the product. So we're squaring the entire product. This is similar to the previous one. We're squaring the multiplication problem. We're not just squaring one number. We're squaring the product of these two things. That's a reminder that we're having a fire drill in about 30 minutes. So we're squaring the multiplication problem between these two things. Actually, it's a similar looking problem where we have the multiplication problem all of that in parentheses is being squared. We're squaring the multiplication problem between these two things. The next one says we're cubing the quantity. So we're cubing the entire quantity. Actually, this is another phrase that kind of groups things. It's saying we're cubing all of this stuff. It's kind of the same thing. We're going to put that in parentheses, 3 plus a number, in parentheses, and that entire quantity, all of that stuff, is cubed. The next one says the product, so the multiplication problem between the cube root of 2 and 9. It's the product of these two things, the cube root of 2 and 9. We're multiplying the cube root of 2, doing the cube root of 2 times 9. Okay, so I'm just going to walk through 6 more examples. They especially compare different phrases that are almost the same. It's just you rearrange it so slightly, like especially the second one. They're the exact same sentence except for this comma. It's going to change the entire thing. So I'm really just trying to compare these two examples and show you the difference between very subtle phrasings so that you can translate effectively on your own. Alright, so the first one is saying that we're going to cube the product of 3 and a number. That phrase is really important. We're cubing the product. We're multiplying these two things, and we're cubing that entire multiplication problem. We're multiplying 3 and a number, and we're cubing that entire product. That's why we need to put it in parentheses. It's telling us to group that so that we can cube the entire product. The second one is saying the product of 3 and a number cubed. So we have the product of these two things, the product of 3 and a number cubed. We're not cubing the entire thing. We have a number that's cubed, and we're multiplying those two things. We have the product of 3 and some number cubed. Alright, the next one is saying 2 less than 3 times a number divided by 7. So 2 less than is telling us that we're subtracting 2 from something. The 2 has to happen at the end. We see that phrase less than. That's telling us we're going to flip these things. And we're flipping the 2 and 3 times a number divided by 7. All of that is one term. It's 3 times a number divided by 7, and then we're taking 2 away from that. 2 less than that entire phrase, 3 times a number divided by 7. The next one is the exact same phrase, it's just got a comma here, so it's telling us to separate these two things. It's saying that this entire thing is together. 2 less than 3 times a number. We're not even going to worry about after the comma, we're just going to write that part out. 2 less than 3 times a number. Oops, not sure what I did there. 2 less than 3 times a number. And then, after that, we're dividing that entire thing by 7. So we're going to put that as a big fraction. 2 less than 3 times the number on top. All of that, separated by the comma, divided by 7. Alright, and the last one, how many times did I get to do that? The last one says the quotient, the division problem, of whatever it's talking about next. The quotient between these two things. The quotient between the cube root of x and y squared. The division problem between the cube root of x and y squared. That's how we write the cube root. It's like the square root, except we put a little 3 on the outside to show that it's cube root and not a square root. So it's the cube root of x and y squared, and it's the quotient between those, so we're dividing. Next one is the exact same thing. It's just a comma in between. We have a comma there, so again, I'm going to do that same thing. We're separating this whole phrase from that squared part. So we have the division problem between the cube root of x and y. So we're dividing those two things, and then we're going to square the entire thing. This is what that's going to look like. We have all of that in parentheses. The cube root of x and y are being divided. That's what quotient's telling us. And we're separating that with a comma, so it's saying this entire thing has to be squared. This one was just saying the y was squared. This is saying this entire phrase is squared.